My name is Luke Callahan. I am a motion picture science major.
Troy Church. I'm an imaging science major.
It's Gabriel Peters. I'm an imaging science major.
Sarah Mallory. My major is imaging science.
And I'm a part of the capture team.
Processing group.
Animation team.
Laser and galvo display.
FIP, or Freshman Innovation Project, is a engineering focused class.
We kind of get a head start with all things imaging science pertaining to our major without actually having to take too many classes.
Really great hands-on experience that people in the imaging science and motion picture science and other adjacent majors get to experience working and trying to develop a hands-on imaging system, and it's really cool.
So we were given a prompt to create a digital mirror that operates with creative methods of capture, processing, and display.
The specific project is simply titled our Fourier laser project, in which we are going to take an image
And we're going to be outlining them using edge detection.
And then we're taking those features and we're altering those specific lines of the features with the Fourier transform.
Animate it so that it draws, and then hopefully by the end of the year we're able to draw it with a laser onto a phosphorescent screen.
We've tested products in a different variety of lighting setups and environments, backgrounds, so we could test if these systems would work with any kind of environment. We just tried to make sure that we had as clean a result as possible before we send it off to processing, whether that be RGB or grayscale depth pictures.
The picture starts out as obviously just an image, and then we run it through what's called a bilateral filter. It also can be viewed as a beauty filter. It keeps edges and also reduces noise and blurs out some very fine detail, but keeps the edges that we're looking for. Then following that, it goes through a canny edge detector, which is a long set of filters that results in very clear and distinct edges using the couple threshold values that we've decided on. And then after that, we create contours, which is essentially a mathematical representation of those edges with a set of lines, or I should say a set of points. And then following that, we're going through a Fourier transform, which represents the contour data using its frequencies, which is a little difficult to explain, but it's essentially how those lines change over time. And so then following the Fourier transform, we're putting a threshold on it, and we're cutting out higher frequency data and keeping some of the lower data. That way we can get rid of some of the fine detail and get a more interesting caricature. And then we're inverting Fourier transform to then get back into the spatial domain that we need, opposed to the frequency domain that it was in previous. And then we have a list of XY points.
And animation is going to take that data and draw it. So we're not just looking at a single screen, it's going to make it more pleasing for the viewer. Right now we're just kind of exploring with single images of a human face, and we're just kind of trying to figure out how we want to prioritize how we draw it. So the whole idea is that we want to draw the outline of the person's face and then kind of go inwards in a spiral motion to kind of capture all the detail. So that's very important. So that's really what we've been working on.
Between this Imagine video and the end of the semester, we want to make a huge leap and try to get a finalized, more artistic way to present our final product to you guys. And that is in a physical laser and a galvo display, where you have a laser and you have a mirror, and the laser is a stationary laser, points at the mirror, and it will hit the mirror, and the mirror can paint the image on a wall or some sort of physical display. And the really cool aspect we want to get with this is we want it to paint the image, and we want it to be a phosphorescent glow-in-the-dark image, which just means it glows in the dark. You have all the lights off, and you can just draw yourself with glow-in-the-dark paint.